P3, the one on factoring, because this section relies a lot on your factoring skills. Now, luckily, a lot of the factoring isn't as difficult as some of the problems you may have seen in P3, but they can still be kind of tough. So the first question on here, it's this section at P4 is on rational expressions. And what's the root word here? Ratio, okay? Now, what's a ratio again? A fraction, okay? So it says, in your own words, what is the domain of an algebraic expression to start off with? What's the domain of an algebraic expression? I mean, you've heard the word domain before, right? Raise your hand if you've heard the word domain. Okay, good. Got everybody. What's the domain of an algebraic expression, Raymond?
At least what I'm thinking is it just the scope of what the answers and the questions can all be of mathematical?
Kind of more than just what the answers can be. We're more interested in what we can plug into the expression. Okay? So what's okay to plug in? Okay? So we'll write that really informally. What numbers are okay to plug in? Now, we say plug in. A lot of times if we get technical, plug in means to substitute in. Okay? Evaluate the expression when we plug something in. Okay? So for most expressions, you can plug in any number you want. Okay? Now, when we say any number, we're usually talking about what type of numbers based on our conversation last week? Any real number. Okay? Any real number is usually what we start off with. But there are three functions, three very common functions, three very common operations that you've got to be a little bit careful with the numbers that you plug in. Okay? The very first one that you were made aware of is you can't divide by zero. If you have division, you better be careful because you can't divide by zero. Okay? Can't divide by zero. That's not allowed. Okay, what's another operation that you're aware of that you have trouble, depending on what the number is, plugging that in and then evaluating that expression? Anybody know? Logan? Very good. Okay, so we're going to say this. We're going to say even root of a negative. Okay, so I'm going to say can't take even root of a negative. Okay, that's not allowed. You can't take the square root of -4. You can't take the sixth root of -27. You cannot take an even root of a negative. Now, is that true of odd roots? What if I wanted to find the cube root of a number? Yeah, if you plug in a negative, it's going to be a negative. If you plug in a 0, it's going to be 0. If you plug in a positive, it's going to be positive. Odd roots don't have that problem. Even roots do. So you can't divide by 0. Got to throw out 0 when you've got a division problem. Okay? If you've got an even root, you can't take the even root of a negative. Okay? But you can take the even root of, remember we'd call it a non-negative number, so 0 or positive. So throw out 0 here, throw out the negatives if you've got an even root. Anybody know what the next one is? This is not most people's favorite. A logarithm. You can't take the log of 0 or a negative, okay? That's not allowed. Raise your hand if you've worked with logarithms before. Okay, most of you, okay, that's good. All right, so can't take log of negative or 0. So I'm going to say this probably dozens of times this year. This will come up again in the other classes that you take once you start taking college math classes. Okay, there are three operations that have domain issues, I like to call them. Okay, division, even roots, and logarithms. You can't divide by 0, so all you have to do is throw out 0 when you're working with division. Okay, with even roots, it's negatives that you can't use. 0 is okay, and when you're doing logarithms, you can't take the log of 0 or a negative. Okay, so please keep those straight. These are going to come up again and again. Okay. So, what is a rational expression? Can somebody describe what a rational expression is? It's a fraction. Thank you, Tony. Okay, it's a fraction. we could maybe add a little bit to that. It's a fraction with, and I'll say usually what does it have on the top and bottom? Sometimes it has integers, okay? Usually has polynomials on top and bottom. Usually, not always. And frankly, I mean, is 1 a polynomial? So if I wrote something like this, 1 over 2x. I mean, 2x is a polynomial. It's a power function. The degree is 1. Would 1 technically qualify as a polynomial, like a power function? Could we call it x to the 0? Would that be okay? Okay, so sometimes they'll just be plain old numbers. Okay, and the next thing is, how do we simplify rational expressions? So let's say I had this. We'll make a really easy rational expression. Let's say I had 2x over 4x. How would I simplify that? Take a good look. Raymond's got his hand up. I think a lot of people know how to do this. How do I simplify that? Yeah?
By factoring.
You factor it, okay? In fact, this is already factored for the most part, but we could be a little more explicit. We could say the top is 2 times x, the bottom is 2 times 2 times x. And then what do? What word do we normally do for this? Cancel. You want to be careful with the word cancel. In this case, they cancel to be a 1, and that's important. Okay, when you're using division to cancel things, they always cancel to be 1. So those cancel to be 1, those cancel to be 1, and then I want to write the final answer here. Final answer has a 1 on the top and a 2 on the bottom. Okay? So, how do we simplify rational expressions? We cancel common what? Common factors. Very good. We cancel common factors, which this is a big deal. We cancel common factors, not common terms, and I'll point that out a couple times. But if we're going to cancel common factors, it's got to be factored. So we're going to have to factor some things. Okay? And we also have to be aware with rational expressions, we have to be aware of what numbers are okay to plug in. Because if you'll notice, if I have a fraction is just a little division problem, right? So if I've got a division problem, I better make sure I'm not dividing by 0. Okay? See the flow here? See how all this fits together? So let's take a look at example number 1 right here. It says simplify and state the domain. So here's what we're going to do. Let's factor this. So I've got to have numbers on the top that multiply to be 30 and combine to be negative 11. This is why that last section was so important, because you've got to be pretty quick at this. We don't want to spend 4 hours trying to factor each one of these. Okay, so I'm going to use negative 5 and negative 6. Those multiply to be positive 30, combine to be negative 11. And on the bottom, I'm going to take out the greatest common factor, and I end up with an x minus a 5. Okay, now, before we go any further, take a good look at this. This is a very nice form that represents everything that was there to begin with. It's also very easy to tell what number we can't plug in. Now, I can plug in a 0 because when I plug in a 0, this one's a negative 5, this one's a negative 6, that's a 3. If I plug in a 0, this is negative 5, so I don't have a 0 in the denominator. So if I want to figure out the domain, what I want to do is I want to figure out when is x minus 5 equal to 0. Because the 3 is not going to make the denominator equal to 0. It's going to be the numerator. Okay? Or sorry, the denominator, that x minus 5 that's going to make it equal to 0. So what would make that equal to 0? Okay, x equal 5 would. So this is what I'm going to cross off. Okay, that's the domain. It's going to be all reals. I think we mentioned this last week. You could say all reals except for 5 are okay to plug in. Any questions there? Is this simplified though? It's not. What should we do? Cancel off the common factor. Now, please don't do this. I've seen this before. Don't cancel those two and those two like that. What you're doing is you're canceling off this entire factor with that entire factor. Okay, that's the right way to do it. You cancel factors, not terms. So what's left on the top is an x minus 6, and what's left on the bottom is a 3. This is the simplified answer. This is the simplified expression. Now, does it look like we can plug in a 5 here? It looks like you ought to be able to, but remember, where did this come from? It came from this original problem right here. And watch what happens if I plug in a 5. I get 3 times 5 is 15, minus 15 is 0. Can I divide by 0? Can I have 0 in the denominator? No. Okay, so does everybody see why we throw out the 5 and how this is the simplified expression? Remember, ask a question if you don't. Okay, take a good look at the next one. Part of that should look really familiar. Let's take a look at this right here. We want to go ahead and factor this. This is it has a name, difference of squares. So this is going to be x minus 3 and x plus 3. Okay, now, is the numerator written in the order that we normally see them? The numerator. Yeah, it is. It's written in descending order. How about this one? No. It's not. Okay, if they write them both in the same order, that's probably okay. But if they write one in ascending and the other one in descending, they're probably trying to trick you. So here's what we're going to do. Everybody watch, please. I'm going to write the negative x first and then plus 3, and then I'm going to factor this. So I've rewritten the bottom. Everybody see that those two are equivalent. And then I'm going to factor this. What can I factor out of negative x and positive 3? Yeah. Yeah, you can always take out a 1, and we always take out the leading sign. So I'm going to take out a negative 1, and there's an x minus 3. Now, once it's factored, then let's figure out the domain. The domain is going to be anything where, well, let's see, we don't want x minus 3 to equal 0, so what number are we going to throw out? 3. Okay, there's the domain. Any number you want, you could say all reals, except x equals 3. You could say from negative infinity to infinity, except x equals 3. And then I simplify this by, I'll cancel off common factors. Now, would I write it like this? X plus 3 over negative 1. Would I leave it like that? Kind of a silly thing to do. There are 3 ways to write a negative fraction. So if I wrote negative 3/4, I can write negative 3/4 this way, negative 3/4 this way, or negative 3/4 this way. So negative on the top, out front, or on the bottom. We rarely write it on the bottom. We usually write it out front or on the top. Top, a lot of times, would be the best place. So what we're going to do is we're going to move the negative on the top, and then I'm going to distribute through. That's going to be minus x minus 3, and there it is. Okay, this is the simplified expression. There's its domain. Okay, let's take a look at this. Little more challenging here. Remember what that one is? Difference of cubes. Perfect cube of x, perfect cube of 4. So this is going to be x minus 4, x squared, 16. That one's positive because we've already used the negative. And what goes right here? What's that term in the middle? Somebody's got to know it, or you didn't study those enough. These are going to come up again. These are going to be on a test in a week and a half or so. Yeah. It's positive 4x. Okay. Remember, each one of these formulas only has one negative. If there's a negative here, it's in the middle of the first one. And then we want to see if we can factor this. This is a little more difficult because it starts off with a 2x squared. So let's see if we can get that. I'm going to do guess and check because there's only one way to make a 2x squared, and that would be a 2x and an x. And let's see if we think about this for just a second. Again, if you need to use grouping, go right ahead. If I put a 4 here and a 1 here, those two would multiply to be positive 4, but there's no way they're going to make a negative unless they're both negative. So let's check this. Do those make 2x squared? Is that the right first term? Positive 4, right last term's there? Yeah. And then that's a minus 1x and that's a minus 8x. Do those combine to be a negative 9x? They do, so that's the right factoring. If you can't do that relatively quickly, we got some work to do here. Okay? Let's talk about the domain. Okay, let's look at this. What number can I not plug into this one right here? Okay, into the x minus 4. Okay, I can't plug in a 4, so we're going to throw out a 4. What number can I not plug into this one? Into the 2x minus 1. Okay, that's going to be a positive 1/2. Everybody see why? What makes 2x minus 1 equal to 0? Remember, we can't have a 0 in the denominator. A 0 is a factor in the denominator. So we add 1 to both sides. So I'd have 2x equals 1, divide by 2. There's my x equals 1/2. Okay? All right, is this simplified, or can I cancel something off? Okay, I can cancel that factor to be 1, so I end up with x squared plus 4x plus 16 on the top, and 2x minus 1. That's the simplified version, but again, that's the domain right there. You can't plug in a 1/2, which you can still see. You also can't plug in a 4. Okay, are there any questions? Okay, now we're going to take a look at some operations. So adding, subtracting, multiplying, and dividing. So which one's easier, 3/4 plus 1/5 or 3/4 times 1/5? The timesing is, right? Lynn, why is multiplying them easier?
Because you don't have to find the common denominator.
Very good. You don't have to find a common denominator. So all we have to do is just multiply straight across. So this is going to be a 3 on the top and a 20 on the bottom. It's that easy. Now, if they had common factors, we might want to cross-cancel before we multiply, reduce the fractions before we multiply, and all that sort of stuff. But it's that simple. On a problem like this, you have to get a common denominator. So the way we get a common denominator is we make the denominators have the same factors. So here's what I do. I take 3/4 plus 1/5, and I need to make those the same. I need a factor of 4 over here, so I'll multiply the top and bottom by 4. What factor do I need over here? I need a 5, so I'll multiply the top and bottom by 5. So here's what we've got. I've got 15 over 20 plus 4 over 20. So put those together. 19 over 40. Yeah, the denominator doesn't change. It's basically saying you have 15 20ths plus another 4 20ths. That gives you 19 20ths altogether. Okay? All right, any questions there? Okay, take a look at the instructions for this next example. It says, perform the operation, then simplify and state the domain. So, started off with multiplication and division. Okay? So, if we're going to do each one of these problems, and I'm going to blow this up a little bit bigger so I've got enough room here. The first thing we want to do is let's factor everything and see if we can figure out what the domain is. So I'm going to change this problem to, this is y minus 2, y plus 2. I've factored that difference of squares right here on the top. This is y squared. I'm going to factor the numerator of this one here, so this is going to be a y and a y minus 2. And we'll factor this trinomial right here. Got to be pretty quick at this. Easy trinomial, we're looking for numbers that multiply to be -6 and combine to be -1. Help me out here. +2 and -3, right? Okay, let's figure out the domain. What numbers do we need to throw out? Let's take a good look. This is the original problem. What number can I not plug into this one right here? To the y squared? 0, okay? Got to throw out 0. Let's look at this next one, the y plus 2. What number would not be okay? What would make y plus 2 equal to 0? -2. We'll throw that one out. And how about this one right here? +3. Okay, so there's the domain. And then let's start canceling common factors. I can cancel off a y plus 2 with a y plus 2. I can cancel off a y with one of those y's. And then I want to write down what's left. What's left on the top is a y minus 2 and another y minus 2. What's the easiest way to write that? Okay, quantity squared. And on the bottom, what's left of this one right here, the y squared? It's now just a y, and then I've got a y minus 3. Okay? So there's the simplified expression. I've multiplied those together. I got this right here. In between, I figured out what was not okay to plug in. Okay, everybody watch, please. Okay, see that y right there on the bottom? What number would make that equal to 0? 0. Did we already throw that out? We did. It's always a good idea to check at the end to see if there's anything else you need to throw out. And the y minus 3. I can't plug in a 3. I've already thrown that out, right? Okay, let's take a look at the next one because this one's kind of interesting. This is a division problem. Do you ever divide fractions? No. What do? Yeah, you flip the second one over and you multiply, okay? So everybody watch, please. I'm going to factor this one right here. Multiply to be negative 12, combined to be negative 1. I got a 3 and a 4. Which one needs to be negative? 4 needs to be negative. And we'll do this one right here. Anybody recognize x squared minus 8x plus 16? It's got a name. Perfect square trinomial. So x here, x here. They're both negative 4. If you wanted to write it as x minus 4 quantity squared, that would be okay. What numbers do I know I need to throw out already? Definitely a 4. Definitely a negative 3. Any questions there? Okay, let's finish factoring this and we'll flip this one over. This is a difference of squares, so this is x minus 6 and x plus 6. The denominator we already factored, that's x minus 4 and x minus 4. I'm going to change this to multiplication, so that means the x plus 3 goes on the top with the x minus 4. And when I flip this over, I'm going to go ahead and factor that at the same time. That's going to be a 3 and an x minus 6. Now, take a look here. Should we throw anything else out? A positive 6, okay? Because that would have a 0 in the denominator. Okay, I'm going to come back to that in just a second. Let's go ahead and simplify this. I can cancel off the x minus 6 with the x minus 6, and x minus 4 with an x minus 4. So when I write the simplified answer, I've got x plus 6 on the top with an x plus 3. And on the bottom, I'm going to slide the 3 out in front just because we normally do that. That's just convention. And then this right here would be the answer. Look at the end answer. There's one number that we know for a fact we can't plug in just by looking at the end answer. That would be a 4. Did we already throw out a 4? We're in good shape there. Okay. Can somebody tell me why we can't plug in a negative 6? It came from up here. It came from the 3x minus 18. Why is that not okay? Why did we have to throw that one out in the end also? We were worried about these two denominators, but we end up also being worried about this one right here. Can anybody tell me why? Yeah. What do you mean? This x minus 6 over here. Sorry, it's hard to see. This one here. Okay. We flipped it over, right? So it ended up in the denominator. I'll take that. What happens if the top of this, the numerator of this one, turns out to be 0? What if that's a 0? What is this whole thing going to be? Say I have 0 over a number. What is this number here? It's going to be 0. So we're taking whatever this number is right here and we're dividing it by 0. That's why. Okay? Might take some time thinking about that. The easy way to do this is factor the denominators, throw anything out there, look at the end result, see if there's anything else you need to throw out. Okay? Any questions? Okay. That's multiplication. Factor everything, cancel common factors, multiply straight across. That's division. Factor. Flip it over. Cancel common factors, and then write down the simplified answer. Let's take a look at the next one, because these next couple, these are addition problems and subtraction problems. What's nice about example C? Yeah, we've got the same denominator here, okay? So we can just combine these. You do have to be a little bit careful, and I'll probably say this a million times this year. This is going to be 4x plus 12 and then minus x minus 2. Take a good look at that. Is that right? People make this mistake all the time. What did I not do correctly? What's the word back there? I didn't distribute, okay? This is minus every one of those terms on the top. So yeah, it's going to be minus x, and it's also going to be minus a minus 2, which would make this a plus 2, okay? So this is going to be a 3x plus 14 over x minus 3. That's the answer. What did I not do, though? I didn't find the domain, okay? So the domain is going to be all x's except for x equals 3, okay? And again, on this one, you kind of get lucky. You could see that in the end answer as well, okay? Any questions? Okay, let's take a look at example D. So I've got x minus 3 over 2x plus 6 plus x plus 2 over x plus 3. Clearly not the same denominators. So I need to get the same denominators, and I'm going to make them the same denominators by making them have the same factors, which means I've got to factor them first. So if I take out a 2, this is an x plus 3. That's an x minus 3. X plus 3 can't be factored, so it's all by itself. And then I've got x plus 2. Okay? Everything's factored there. Now, how do I make them have the same factors? Is this one missing anything? This first one, the 2x times x plus 3? Nope. Is the other one missing anything? Yeah, it is. It needs a 2, so I'm going to multiply the top and bottom by 2. Please make sure you put the numerator in parentheses here. If you don't, and just write down 2x plus 2, you're going to get it wrong. So here's what we get. We get x plus 3 plus 2x plus 4 on the top, and I get 2x plus 3 in parentheses on the bottom. A little bit more work to do. What do I need to do? Yeah.
Why is it x plus 3?
Oh, it should be minus, shouldn't it? Thank you. Thank you. Good there? So I get 3x on the top plus 1, and I get 2 and x plus 3 in the denominator. You should probably leave your answer like this. By leaving it like that, you can see there aren't any common factors. In other words, this can't be reduced at all. Okay? Any questions? What's the domain? Yeah, x not equal to negative 3. Okay? Good? Okay, let's take a look at this one right here. Again, we need to make these have the same denominators by making them have the same factors. So we're going to factor this. I need numbers that multiply to be negative 2 that combine to be negative 1. So that's going to be positive 1 and negative 2. I need numbers that multiply to be negative 8 and combine to be positive 2. So that's going to be positive 4 and negative 2. And I've got a 2 here and a 10 here. I make the denominators the same by making them have the same factors. So Nathan, what do I need on this first one right here? This you do. You need an x plus 4. So I'm going to multiply that by x plus 4 and that by x plus 4. Again, make sure it's in parentheses. Brandon, what does the second one need? What are we missing? What factor?
X plus 1.
Need an x plus 1 here, so we're going to multiply by x plus 1 here. So our denominator is going to be an x plus 4, an x plus 1, and an x minus 2. And then I get, I'll go ahead and distribute through, 2x plus 8 plus 10x plus 10. Did I make any mistakes? So we're going to have a 12x plus 18. Okay, should I leave it like that? On a test, your goal is to convince me you know everything there is to know about these problems and you really know what you're doing. Is this factored completely? The numerator? No, you might want to take out a 6. You're left with a 2x plus 3. And the reason you'd want to do something like that is if you look at this end result right here, you can tell we've canceled everything that we can. It's completely simplified because you can see that this 2x plus 3 on the top will not cancel with any of those on the bottom. Okay? And Peyton, what have I left out? Domain. What can't I plug in here? 2. Negative 1. Negative 4. Very good. Any questions? Sure? Okay. What's the difference between E, make this a little smaller, what's the difference between E and F? It's a minus. And what would you have to be careful with? Does it change the fact that you've got to get the same common denominator? No, but what do you have to be careful with? Yeah, you better be careful distributing. So here's what we're going to get. This is going to be, and I'll change colors here, I'm going to do this in blue. This is going to be a minus. So the denominator is going to be the same. We're going to have an x plus 4 and an x plus 1 and an x minus 2. But up here we're going to have a 2x plus 8, and then we're going to have a minus 10x, and we're going to have a minus 10. Correct? The numerator then is going to be a minus 2x minus a 2. Is that right? And the denominator is still the x plus 4, x plus 1, and x minus 2. Are we done?
Minus 8x.
Should be what? Tell me again.
2x minus 10x is negative 8x.
Oh, negative 8. Thanks. Thanks. Okay. Are we done with this one? Probably take out a negative 2 and you're left with 4x minus 1. Can I cancel that factor with anything in the denominator? Nope. But that's probably the best way to write it. Again, just get rid of that in the interest of time. Any questions? Raise your hand if all this is easy. Got some waving hands, all right. Okay, go ahead and flip the page over. Okay, now we're going to talk about something called a complex fraction. Can anybody tell me what a complex fraction is? Let's see, Raymond's answered a couple times. Anybody else? Lynn? Dividing a fraction by a fraction. So it's a fraction with fractions in the numerator and or the denominator. It doesn't have to be both. Usually it is both. So you'll notice on this one right here, on example A, we've got a fraction in the numerator and in the denominator. Okay, now there are generally two techniques for taking care of problems like this. Here's the way I like to do it, and I think in the long run, this is better. The other way is a shortcut, but if you understand the shortcut really well and can do it regardless of the situation, then that's fine, but I like this way. What we're going to do is we're going to treat the top and the bottom separately. I'm going to get a common denominator and put these together. So this is going to be 2 over x minus 3x over x. Got a common denominator there. So I have 2 minus 3x over x. I need a common denominator on this one. So I'd need an x minus 1 here and an x minus 1 there. So this is going to be x minus 1 is my common denominator, and then I'm going to have x minus 1 minus 1. Any questions? So this is going to be x minus 1 on the bottom, and this is going to be x minus 2 on the top. I now have this fraction up here divided by this fraction down here. Do I ever divide fractions? Nope. I'm going to take this one, and I kind of just envision that just flipping over, just kind of rolling over like this. That's going to put the x minus 1 on the top and the x minus 2 on the bottom. It's now a multiplication problem, and I factored everything. Does anything cancel? Nope. So here's the answer. The answer is going to be 2 minus 3x over x minus 2, and we're going to multiply that by x minus 1. And the good part is you can leave it that way. This is okay. What would usually be better is this. I'm going to rewrite this as negative 3x plus 2, and I'm going to factor out a negative. So if I take out a negative, I've got 3x minus 2, x minus 1, x, and x minus 2. Any questions? Okay. Sure? We didn't state the domain though. And the domains on these are a little bit tricky. So we have to remember that this final answer came from this original problem. So let's take a look at the numerator right here. 2 over x minus 3. What can I not plug into that numerator right there? Can't plug in a 0, so I better throw out a 0. Let's look at the denominator of the original problem. What can I not plug into this 1 over x minus 1? I can't plug in a 1. Okay? Now, let's take a look at the end result here. Look in the denominator. There's an x. Can't plug in a 0. I also can't plug in a 2. So make sure you get all of those. Okay? So again, look at the original problem, throw out anything that's not good there, and then look at the end result and throw out anything that's not good there. Any questions? Okay, let's do the same thing on this one. Or do you get the idea? Raise your hand if this is pretty easy. You've seen complex fractions. Okay, let's do one other one. Okay, so on this one, again, I'm going to get a common denominator. So this is going to be x, and 2, I need an x plus 2. Then minus, this is x plus 2, and this is a 2. What do I need here, Sven? Denominator of this one right here? I need an x. So that's going to give me x plus 2. This is going to give me 2x. I'm going to do the work over here. 2x plus 4 minus 2x. Well, this is cool. What's the numerator here? Just a 4. Okay, now let's do this denominator. Well, gosh, there really wasn't any work to do, right? So this is kind of cool. I have a single fraction on the top and a single fraction on the bottom. Once I have that, then I can flip that denominator over and I can multiply. So I'm going to take that one and I'm going to flip it over, and I get an x plus 2 on the top and I get a 2 on the bottom. Tony, what can I do here now? What can I do right here? I'm going to multiply them together. So I could just, multiply everything on the top together, but what else do I notice that I can do? Okay, I can cross cancel. So 2 goes in here once, 2 goes in here twice. What else can I cancel, Noah?
X plus 2.
That factor of x plus 2 with that factor of x plus 2, and take a good look at this. Notice that the only thing left in the numerator is a 2. What's the only thing left in the denominator? An x. There's the answer. Write down the domain. You look through and find the domain and then check that with your neighbor. See if you got it right. Tara, what number for sure do we need to throw out? Definitely need to throw out a 0. Okay? And what else? And a negative 2. Okay? Anything else? Oh, if we look back at the original problem, 0 here, negative 2 here. Nothing in the work would suggest otherwise. And when you look at the final answer, you also can't plug in a 0. So those are the 2 numbers that are not in the domain. Okay, are there any questions? Okay. Here's what we're going to do. I am going to I'll make a recording of these last couple problems right here. I'll post it online. Does everybody know how to get to my website? I showed you that before. Okay. I will post this online, and we've done about 40 minutes right here. So if you will look on the website at some point, you know, probably the end of school, I'll probably have it up there by noon though. Just watch maybe the last 10 minutes. Skip the first 40 minutes, just fast forward and watch those last couple, and then fill in the notes. If you do it here at school, these computers will work. You just might need to have an earbud or something. Okay. Any questions? Okay. All right. Try and have that done try and have P4 done tomorrow morning, okay? So we can correct it.
The first, the one that just before we did, I don't think that one is hard to get in.
On which one?
This one?
Right, yeah, we threw it out.
But why is that wrong?
Because if you try and plug in a 1, this part of the original problem would be undefined.
Got it.
That makes sense.
And also, I feel like I got one of the questions right. I was just wondering, what is the answers?